Okay, everyone. So from the last topic of the last class, I just gave you a question: 10% weight by volume, calcium carbonate. Calculate the molarity of CaCO3, Ca plus 2, and CO3 minus 2. Alan, will you be able to solve it?
Yes, sir.
Okay, thank you. Let me know the answer.
So I said 5.2 10 raised to minus 5.
5.2, it's wrong, I think. Wait a minute. Alan, can you repeat your answer?
5.2 into 10 raised to minus 5.
5.2.
Into 10 raised to minus 5.
Oh. What is the formula for molarity?
Number of moles by volume of solution liters.
Okay. So see, from here we can conclude that it will be, this means that 10 gram of calcium carbonate present in 100 ml of solution, right? Sakina, is there any answer from you?
Sir, I'm still here.
Okay. 10 gram of calcium carbonate present in 100 ml of solution. Now, as you can see, I'm going to apply the formula of molarity. Molarity is equal to basically number of moles of solute upon volume of solution in liter. So what is number of moles of solute? Number of moles of solute has a formula which is not given. Number of moles of solute is not given directly, but we can calculate given mass upon molar mass. What is the given mass? Given mass of solute is 10 gram. CaCO3 is your solute, so here it will be 10. And what is the molar mass of CaCO3? 100. So the moles that you have got is 1 by 10 moles. Now, volume of solution in liter, volume is given as 100 ml. Solution has a volume 100 ml, and we can easily convert it into liter by dividing it by 1000. So the volume will also be 1 by 10 liter. Now you are going to put the value. Number of moles of solute is 1 by 10. Volume of solution in liter is 1 by 10. And you will get 1 mole per liter and 1 m. We can also write 1 capital M. How did you get Alan 5.2 into 10 raised to the power?
I thought we'll use the KSP solution from equilibrium chapter.
No, no, no. This is simple molarity formula we can apply here. So now you can see you have got the molarity of CaCO3, that is 1m, and we are going to calculate the molarity of ions. So you need to dissociate into ions, and you know there will be Ca plus 2 and CO3 minus 2. So after dissociating into ions, you need to check whether it is balanced or not. So you can see this is 1 mole, this is 1 mole, this is 1 mole, and basically this is balanced. So we can directly compare in terms of molarity. One molarity of this will give one molarity of this and one molarity of this. And how many molarity, how much molarity of CaCO3 we have? One. So the molarity of CaCO3, if it is 1, then the molarity of Ca plus 2 will also be equal to 1m, and molarity of CO3 minus 2 will also be equals to 1m. Is that clear?
Yes, sir.
Okay, please do write it. Let me know when you are done with this. Let me know when you are done with this.
Yes, I'm done.
Okay. Sakina,
Yes, sir, done.
okay. Now we are going to have the next concentration term, that is molality, which is represented by a small m. Now I'm going to define it. Molality is number of moles of solute per unit mass of solvent in kg, per unit mass of solvent in kg. So as you can see, Molality is number of moles of solute per unit mass of solvent in kg. This is the only concentration term in which we will use solvent in denominator. Except this, we always use the solution's mass or volume in denominator or solution's moles. So we can also have an equation for this, a mathematical formula that will be equal to number of moles of solute upon mass of solvent in kg upon mass of solvent in kg. So this is the formula, and from this formula you can easily calculate the unit as well. Unit of molality is equal to number of moles of solute upon mass of solvent. That means basically moles per kg. This is the unit of molality, or either you can directly use a small m in the way that you used for molarity. Is that clear? Now I'm going to give a question on this. 50 gram of CaCO3 present in 500 gram of water. Calculate molality. Please do this. Are you done with this? Are you done with this? Sakina, uh, Alan, you have got 0.5 watt. What is the unit?
0.5 amp.
0.5 m. Okay, I'll just check it. Sakina, is there any answer from you?
No, sir.
Okay, it's very easy. Just wait a minute. No, see,
No, so molarity is one. 0.5 is an moles.
0 point.
0.5 is the moles. The number of moles is 0.5, so molarity will be 1 mole per liter.
Yes. 1 mole per liter, not per liter. We are calculating molality, so it will be mole
Okay,
per kg.
okay,
So
mole per kg.
for molality, you just need to extract information from the question, that is what is given. So you can see this is your solute and this is your solvent. So molality as a formula, which is number of moles of solute upon mass of solvent in kg. This is the mass of solvent. We need to put the mass of solvent in kg. Now you can calculate the number of moles of solute, which has a formula given mass upon molar mass. Now given mass is 50 gram and molar mass of CaCO3 is 100. If you are going to calculate it, you will be getting number of moles as half mole. And now mass of solvent in kg, we need to keep it in kg. So 500 gram divided by 1000, it will be now in kg, and it will be also equal to half kg. Now you are going to put the value, it will be half, and it will be cancelled. So it will give you 1 mole. Here you can see in numerator you have mole and in denominator you have kg. So 1 mole per kg it is. Is that clear?
Yes, sir.
It's so easy, Sakina, isn't it?
Yes,
Now I'm
sir.
going to give you another question. Yeah. 10% weight by weight, CaCO3 in aqueous solution. Calculate molality. Molality is very easy. Uh, Alan, are you done with this?
No, so I'm still doing it.
See, I'm gonna explain. You're taking a lot of 10% weight by weight. What does it mean, Sakina? 10% weight by weight. Alan, Sakina, are you there?
So 10 gram of CaCO3 and 100 grams of solution.
Very good. 10 gram of solute, that means CaCO3, and 100 gram of solution. Now, as you can see, we need to calculate molality. So the formula of molality is number of moles of solute upon mass of solvent in kg. So we can easily calculate the number of moles of solute, which has a formula given mass upon molar mass. Now, when we are going to calculate mass of solvent, as you can see, mass of solute is given and mass of solution is given. So what will be the mass of solvent, Alan? It will be mass of solution, that is 100, minus mass of solute. This will give you mass of solvent, which is 90 gram. Is that clear? Now we need to convert it into kg. Basically, when we are
Yes,
going to
sir.
put the value, it will be divided by 1000 because it is in gram. So 10 by 100 into 1000 upon 90. So we can easily cancel this. Now what you will get 10 by 9. This will be your moles per kg. Isn't it easy? Sakina, why are you not responding?
Yes, sir.
Have you got it?
Yes, sir.
Can I change the slide? Alan?
Just a minute,
Yes,
sir.
sir.
Okay. Sakina, are you done with this?
Yes, sir.
Please do calculate. Alan, are you done with this? Alan, Anushka,
No, sir.
will you be able to solve it or should I explain? Sakina,
Sir, can you explain?
okay, see, it's very easy. 46% weight by weight C2H5OH is given. So what you can write about this? From this, you can write 46 gram of C2H5OH, that means solute, present in 100 gram of solution. 100 gram of solution. This is the given. Now, what we need to calculate is molality. Molality is equal to number of moles of solute upon mass of solvent in kg. Now, as you know that this is your solute, so you can easily calculate the number of moles of solute that will be equal to given mass. And given mass is your 46 gram. And if you are going to calculate the molar mass of C2H5OH, it will be equal to 46. So the mole that you have got is 1 mole. But in denominator, we need to calculate the mass of solvent in kg. But here, mass of solute is given, mass of solution is given. So can't you calculate the mass of solvent? Mass of solvent will be equal to mass of solution minus mass of solute, because solute plus solvent is equal to solution. So solvent will be equal to solution minus solute. So here you can see it is 100 minus this is your 46. So this will be your 54 gram. Mass of solvent is 54 gram, but we need to convert it into kg. So you can do that easily. Now number of moles of solute is 1. Mass of solvent is 54 gram, and for to convert it into gram in kg, we need to divide it by 1000, and it will be 1000 upon 54. That means it will be equal to 500 upon 27. Either you can write moles per kg, or either you can write 500 upon 27 m. You can divide it. So the previous question and this question was too easy. It was similar. Still, you are not able to solve it. Please do let me know when you are done with this. Are you done with this?
Yes, sir.
Okay, just wait a minute. Alan, are you done with this?
Yes, sir.
Okay. So I'm going to give you the last question on this. Please do solve it. And it is 20% weight by weight, NaOH in aqueous solution. Calculate molality. Let me know if you are done with this.
So I'll say 6.25.
6.25, very good. Is there any other answer from Sakina and Anushka?
Yes, sir, same answer.
Very good. Sakina, what about you?
Sir, I didn't get it.
What is the problem? Are you unable to solve it, or you are stuck
Sir, I'm
somewhere?
unable to solve it.
Have you understood the previous one?
Yes, sir.
Then why you are not able to solve it? What was the step? What I did at the first place? Can you tell me? Just extract information from here. What you have written for this one? Please do. Please let me know what you have written for this one. 20% weight by weight. Sakina,
Sir, 20 by 100.
20 by 100. Are you concentrating in the class? Yes or no? Did I write 20 by 100 for this one? Did I write 20 by 100 for this one?
No, sir.
Then what's in your mind? Can you please tell me?
Sir, but
You
it is
just
10 by 100.
10 by 100. What does it mean? What does this 10 and 100 represents?
Sir, solute.
Can you be more specific? Which one is solute?
Sir, 20% is the solute.
20% is the solute, or 20 gram is the mass of the solute? Uh, in the first class, when we started this chapter, weight by weight percent, you were there. So I told you in that class, whenever this type of you are going to see percent weight by volume, volume by volume, you are going to write a whole sentence about this. Did you write it? Yes or no?
Sir, whole sentence of what?
From this, did you write the extract information from this? What does this means? 20% weight by weight. What does this means?
Yes, sir.
What did you write about this?
Sir, it is the mass of NaOH.
Only this information you got from here.
Yes, sir. The mass of NaOH is 20 gram and the mass of solution is 100.
So why are you not able to write it the way I'm writing from the last two questions? 20 gram of solute, that means NaOH present in 100 gram of solution. Is it tough to write it, or you are not? You don't want to write this sentence?
Yes, sir. I wrote this.
You wrote this, then you should tell me now. When I asked you what does this means, what it stand for, what you have extracted from this, so you should write it. What is the formula of molality?
Sir, mass of solute by
Very
volume
good,
of solvent.
very good. Again, repeat it.
Mass of solute
Molality,
by
mass of solute.
volume.
Can you see your notes, and can you please tell me the formula of molality?
Yes, sir. Mass of solute by
You
volume
have
of
written
solvent.
mass of solute for molality. Can you look at it?
No, sorry. Moles of solute by volume of solvent in kg.
Volume of solvent in kg.
Yes, sir.
Have you written it?
Yes, sir.
Please see that again and repeat it. repeat it. Mass of moles of solute upon
Volume of solvent.
volume of solvent. You have written volume of solvent, right?
Yes, sir.
Solvent in kg. Okay, so what 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 should I do? Can you read the formula from here? What I have
Yes.
written here?
Yes, sir.
Yeah, please read the formula for me.
The number of moles of solute by mass of solvent in kg.
And what you just told me.
Sir, I said the same thing.
You said the same thing. That means I made a mistake here. You told me that volume of solvent in kg. That's why I was repeating. It will be mass of solvent in kg, okay? Sakina,
Yes, sir.
okay. Can you calculate the moles of solute? Number of moles of solute? Please do let me know. It will be given mass upon molar mass, yes or no?
Yes, sir.
What is the given mass?
Sir, 20.
What is the molar mass of NaOH?
40.
You have got the value of number of moles of solute, that is half mole. Now
Yes,
you
sir.
need to calculate the mass of solvent in kg. So if mass of solute is given, if mass of solution is given, can you calculate the mass of solvent? Can you calculate the
Sir,
mass of
sir,
solvent?
how?
Yes. What you are about to ask something.
Sir, how will we calculate the mass of solvent?
Very good. That means you are not in class, right? You are not focusing in class, or might be you are using social media, because in the last two questions, I told you how to calculate mass of solvent. As you know that solute
Sir,
plus
is it
solvent
100
is
minus 20?
very good. Now your mind will work like Einstein. Solute plus solvent is equal to solution. So mass of solvent will be equal to solution minus solute. In this question, I also told you. In the previous question, you can see here, I just did the same. And in the third question, I gave you to do this. So what you need to do? Mass of solvent will be equal to 100 minus 20. That is the this is what you told me at last, right? And this is in gram, right, Sakina?
Yes, sir.
So what you need to do? Just put the value in kg. So as you know, mass or moles of solute, you just calculated half. Mass of solvent is 80 gram and divided by 1000, because we need to convert it into kg. 1 by 2 into 1000 by 80. So this will be cancelled. This will be cancelled, and 25 by 4 moles per kg, or either you can write 25 by 4 m, which on dividing you will get 6.25 m. So you should concentrate in the class, because you have very less time left for your board exams. Just let me know so that I will move to the next topic. Before that, I would like to give you a question. Are you writing it?
Yes, sir, done.
Okay. Please do it. Then, did you send this 0.018? Anushka, have you solved it?
Yes, sir.
So no, but I was same as 0.018.
Did you send this 0.018?
No, sir.
Who sent it?
I sent Anushka.
Okay, Anushka, that's great. It's correct. Actually, uh, the name was not shown to me. Mm. Alan, have you got it or should I explain?
No, sir, I got it.
Sakina, what about you? This is a different question from the previous one. Just let
Yes,
me know
sir,
if
I
you
got it.
0.018.
Yes, sir.
Okay. So if anyone want to ask, you can ask this. This is a question that is repeated twice in NEET. It's a very good question. If you want to ask, you can ask me. Okay, let's move to the next concentration term, and that is your normality. The last concentration term, normality. And this normality, before starting this normality, we need to go through two terms. The first one is equivalent, and the second one is number of gram equivalent. Number of gram equivalent. We are gonna discuss one by one. Please do write. So we are going to start this equivalent weight, or you can call it equivalent mass. Equivalent mass. Now, as you can see, equivalent weight has a formula. Equivalent weight will be equal to molar mass that you can easily calculate of any compound, right? If you know the atomic mass upon X. This is the formula for equivalent weight. This is the formula for equivalent weight, which is basically molar mass upon X. X is basically this X is your called valence factor, or we can call it N factor. Valence factor or N factor. So how we are going to calculate this N factor or valence factor? It's very easy. So first of all, you are going to write it, and please, this normality is similar to molarity, but in this normality, we have two more steps. That's why you need to be careful here. So first of all, you're going to write it and then let me know so that I will start explaining what is this X. X is basically known as N factor or valence factor. Please do let me know when you are done with this.
Yes, sir.
Very good. Now see, this X has three parts. The first one is acid, the second one is base, and then salt. You can easily recognize which one is acid, which one is base, and which one is salt. So how we are going to calculate the value of X if it is X? How we are going to calculate the value of X if it is acid? So in acid, X is equal to number of H plus given. Number of H plus given. So if there is an acid that is HCl, so can anyone tell me how many H plus HCl will give? How many H plus HCl will give? Alan, Anushka,
So one.
1 H plus give. It will give 1 H plus. You are going to balance it and you will see only 1 H plus it will give. So if you are going to calculate equivalent weight of HCl, this has a formula, molar mass. Whatever is the molar mass of HCl, you can calculate by adding the atomic mass of each element divided by X, and X here will be 1. So for this HCl, X has a value that is 1 because it will give only 1 H plus. If you are going to calculate the X for H2SO4, can anyone tell me how many H plus H2SO4 will give?
Two.
2. It will give you 2H plus SO4 minus 2. You just need to dissociate it and balance the equation. You will get it. So if you are going to calculate equivalent weight of H2SO4, it will be equal to molar mass, that is 98. It will have a molar mass of 98 divided by X, which has a value 2, because it gives 2H plus. That's why. Now you understand how you are going to calculate the value of X. If it is an acid, then X will be equal to number of H plus, and if it is a base, then X will be equal to number of OH minus given. So if you have NaOH, that is sodium hydroxide, then how many OH minus it will be given? It will give
Sir, 1.
1. So equivalent weight of NaOH will be equal to molar mass of NaOH divided by 1. The value of X of NaOH will be 1. Now if you have MgOH whole twice, so how many OH minus it will give? It will give 2 OH minus. So the value of X for this base will be equal to 2, and equivalent weight will be equal to molar mass of MgOH whole twice upon 2. Is that clear? So isn't it easy?
Yes, sir.
Now you are going to calculate the value of X for salt. X will be equal to, either you are going to take total positive charge, or either you are going to take total negative charge. You just need to deal with the magnitude, not the sign. Like if you have a given a salt, that is NaCl, you are going to dissociate it and you will see Na plus plus Cl minus. Since it is a salt, there will be overall charge. If you are going to count it, it will be 0. On the left hand side, there is no charge. On the right hand side, +1 -1, which will, you are going to add it, you will be getting 0. So the value of X, either you can take the positive charge or negative charge. Only the magnitude you can see +1. So you can take either 1, or -1, you can take 1, because the positive and negative charge will be equal. Now you can see, if you are going to calculate the equivalent weight of NaCl, that will be molar mass upon X, that is 1. If you have CaCO3, which is a salt, so you are going to dissociate it, Ca plus 2 or CO3 minus 2. So you can see X has a value 2, because either you can take the positive charge or negative charge. Both are equal. Both will be equal. So equivalent weight of molar CaCO3, molar mass upon X, which has a value 2. Okay, so please do write it. Molar mass you can calculate, right?
Yes, sir.
Sakina, if you have any doubt in this, please ask me.
No, sir.
Let me know when you're done with this. Everyone done with this?
Yes, sir.
Yes, sir.
Okay. So here is how we are going to calculate the equivalent weight. So calculate equivalent weight of HNO3. Please do calculate. Are you done with this?
Yes, sir.
What is the answer?
Sir, 63.
Very good. Equivalent weight has a formula, molar mass upon X. So molar mass of HNO3 is 63 and it is an acid. If you are going to see, it will give only one